So we're going to be going over the study guide for the Chapter 7 quiz, which is on similar triangles and parallel lines that cut transversals into similar proportions. So for number one here, we have two triangles. Now it says assume the triangles are similar. We could actually prove it if we want to by saying, okay, here's two vertical angles, those are congruent. And since I have parallel lines, we have this little Z pattern here, which will give us alternate interior angles, which will make those congruent. And then by AA, the triangles have to be similar. But we don't need to. Usually when you have this little bow tie formation and you have two parallel lines, the triangles are going to be similar. But let's look at finding x here. So we need to make sure we put the right pieces in our fraction. So I'll have a fraction here equals a fraction there. And we want to start with the solid numbers. So here we have 18, and here we have 12. And we're going to link those two up together. Now, why 18 and 12? Why not 18 and x minus 1 or 12 and x plus 3? Well, if you look here, again, like that little z pattern I showed before, if you look at the angles that are congruent, this angle right here would form an alternate interior with this angle right here. And these two angles would be vertical, so they'd be congruent. So 12 is between the double and the single, 18 is between the double and the single. So these two would match up. So it's like this triangle is being turned this way to kind of fall in place with that triangle. So this angle P is going to go over here to angle L, and that would cause 12 to go over here to 18. So even if they don't tell you to prove they're congruent, you do have to kind of think about how they are, sorry, similar. You have to kind of think about how they are similar in order to match the pieces up correctly, because it's a very easy trick to get messed up on. And then we have x minus 1 is going to go to x plus 3 because, again, they're both on the bottom. That's kind of easier to see. So we have x plus 3 first because I did 18 first. So x plus 3. And then bottom we have x minus 1. So now we just cross multiply and solve. So we do there to there, there to there. We get 18x minus 18 is equal to 12x plus 36. And we go ahead and solve this through. So I'd subtract 12x from both sides, just like I would any normal equation. And I get 6x minus 18 equals 36. Then I add 18 to both sides. And then I get 6x is equal to 54. And then I finish it off by dividing by 6. And I get x is equal to 9. And then that's it. So again, it's all about setting up your correct fraction, cross multiplying, and getting your value from x that way. The tricky part is, again, knowing which numbers to put over which. So in this here triangle, we actually can have two ways of doing this. We have x plus 5, 6x plus 2, we have 8, and we have 24. Now we could use similar triangles and do something like 8 over x plus 5 is equal to 24 over these two together. But if we know that this is 8, then we do a quick little math here and say 8 minus 24, well, that gives us 16 here. So 8 minus 24 would give us 16. Well, in that case, we can use the parallel line the parallel line proportions rather than the triangle proportions. So the parallel line proportions say that these two together are going to be the same as these two together in terms of a fraction. So x plus 5, 6x plus 2, those two pieces are going to be equal to 8 over 16. So again, it's top and top are similar to bottom and bottom. So top and top fraction, bottom and bottom fraction. Now to make this a little bit easier, you can reduce your fraction. So you can go x plus 5 over 6x plus 2. That really can't be reduced because there's x's involved and there's no common number. But 8 over 16 can be reduced to 1 over 2. Divide the top and bottom by 8. So now our cross multiplication gets a little bit easier because we just have a 1 involved. So 1 and 2, so multiply that. Oop, I didn't really make that go over that far, did I? So we have 2x plus 10 is equal to 6x plus 2. We subtract our 2x from both sides. And we get 10 is equal to 4x plus 2. Subtract our 2. We get 8 is equal to 4x. and then just like last time, we finish it off by dividing by 4, and we get 2 is equal to x. So once again, a very easy idea to do as long as we can set up our fractions correctly. So when you're setting for fractions, before you cross multiply, just make a double check and make sure that it makes sense. So in this case, top to top, bottom to bottom, we're all good. In this case, it was this angle and this angle because they're this side and this side because they're between the two angles, and this side and this side because they were both on bottom. So these here, again, similar idea, just different diagrams. So this is much like the last one. It's a little bit of a bigger picture and has more parallel lines, but it's the exact same problem. It's this side to this side and this side to this side. So I have 8 over 6. You can say top to bottom if you want. 8 over 6 and 10 over x. And just like last time, if you want to, you can reduce your fraction. So instead of 8 over 6, I can write 4 over 3. And then 10 over x is going to stay 10 over x because there's no simplification there. And then again, it's just cross multiplying. 4 times x is 4x. 3 times 10 is 30. Divide by 4. And you get x is equal to 7.5. So once again, very similar process to the last ones, just a different picture to go across. If you plug 7.5 back in, and you do, like say we know as 7.5. If you want to check your work, you can say 7.5 over 10 and 6 over 8. Those should both give you the same number. So this should get you 0.75, this should give you 0.75. If it does, great, you got the right answer. If it doesn't, you might need to go back and check your work. But that's a way you can see if you got the correct answer or not, is plug it back in and make sure the fraction still holds. And the last one here. This has to deal with altitudes, medians, and bisectors. So this line right here, we would consider an altitude because it's a right angle. So if it goes from the corner to the end and it's a right angle, we call that an altitude, or the height of the triangle, same thing. And so we can make our fractions here. So it's altitude over altitude. Let me make that a little bit better. So altitude, there we go, so we can actually see it, over altitude. So 42 over x is equal to base over base, or side over side. So 45 over 30. So once again, these are big numbers, so I would simplify them down. So 42 over x is equal to, and then I divide these both by 5, we get 9 over 6, and then I can divide them by 3, so we end up with 3 over 2. So I divided this by 9, and then divided it by 3, and I divided this by, divided it by 5, and then divided it by 3. And then this one I divided by 5 and divided by 3. So divide by 5, and then divide by 3. That will give us this simplification. Or again, you could have just divided by 15 right away if you saw that. So now we cross multiply. We get 90 is equal to 3x. We divide by 3, and we get 30 is equal to x. Oh, sorry, I did that wrong. My bad. Those of you watching can probably see my mistake there. I did 90 times 45, or sorry, 2 times 45 rather than 2 times 42. So 2 times 42 would actually be 84, and x times 3 would be 3x. And then we divide by 3, and we get 28 is equal to x, which is much more reasonable. Because of course it can't be 30, otherwise 42 over 30 and 45 over 30 would not end up being the same number. So once again, if I plug that back in, I could have checked my work and see that it wouldn't go like I had planned. So I'd go back and say, oh, 2 times 42 isn't 90, it's 84. So that was my mistake there. So once again, these types of problems, you just have to figure out what numbers are going to go over which. And again, it's piece over piece. So altitude over altitude, top over bottom, side over side. Just, again, double check your work when you're setting up your fractions so you don't make the same mistake I did, and you should be okay. So these are checking to see if they are similar. And if they are similar, we have 3 different ways of identifying it. Angle, 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 side, and side, side, side. This is probably the most common one if we have all 3 sides, of course. If we just have angles, usually this one's the most common one. If we have a mix, then we obviously use this one. So side, side, side similarity is just simply taking all 3 sides, putting them as fractions, and see if they come out to be the same fraction. And it's big over big, middle over middle, and small over small. So the biggest one here is 18. The biggest one here is 6, so we'll start with those. We'll do 18 over 6. 15 and 5 are the middle pieces, so 15 over 5. And then 6 and 4 are the smallest, so 6 over 4. We want to see, do these fractions come out to be the same, either by reducing them or by dividing them out. So in this case, 18 divided by 6, that just give me a solid 3, or 3 over 1 if you want to keep it as a fraction. This would give me a solid 3 over 1 too, so we're looking good. This right here would give me a 3 over 2, which is not good, because it should be the same as these here. So these would not be similar, so not similar. And how do we know they're not similar? Well, I guess you could say by SSS. So if they were similar, these would all three be congruent. But since they're all three not congruent, we have one oddball out. By SSS, they are definitely not similar. So let's look at another one here. So this one we have a mix. So we're going to be using side angle side here because we have a mix of angles and sides. If we just had an angle, or sorry, if we just had two angles, then we can use angle, angle, angle. Or angle, angle in this case. But we only have one angle. And if we have all three sides, we can use side, 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 but we don't have two sides. So since we have a bit of each, we have to use side, angle, side to help us out, and let's see if that goes well. So first, we still need to check our sides. So 8 is the biggest, 4 is the biggest, so 8 over 4. 6 and 3. So 8 over 4, that's 2 over 1, good. 6 over 3, that's 2 over 1. That's good. So my two sides are similar. So I have a similar proportion between all two sides. And then I know that my angle is congruent. So 80 is indeed congruent to 80. If you want to state that's by reflexive, because again, it's the same angle, just different position. So because the two sides are similar, and because the included angle is congruent, we say they are similar by side angle side. These two sides are similar, 2 over 1, 2 over 1, and this middle piece angle is congruent to itself. Having a little tongue tied today, my apologies. So again, an angle, angle, angle example would be something like if I had a triangle here, that's definitely not a triangle, let's try that again. If I have a triangle here, and a triangle here, and I gave you, say, that this angle was congruent to this angle, and this angle was congruent to that angle, then we conclude they're similar by angle, angle. Because we have two congruent set of angles, so we're similar by that. In this case, I just had one, so I had to use the sides to help me out to fill in the gap. And the last one's a word problem. So we have the Tower of Babel cast a 6,250 cubit long shadow. A cubit is simply just a way of measuring something. It's just a unit of measurement. We have Adam, who is 6 cubits tall, cast a 7.5 cubit shadow. How tall is the Tower of Babel? Well, let's draw a picture here to help us out. So we have the Tower of Babel here. You can decorate however you want. Not really important. And then we have Adam standing over here. So the Tower of Babel's shadow is 6,250 units long, cubits long, however you want to say it. And Adam's shadow is 7.5. And Adam himself is 6, and the Tower of Babel, we don't know. That's a mystery to us. So we want to figure out how much is x. Okay, well, let's set up our ratios here. So shadow over shadow. So I'll do 7.5 over 6250. Shadow over shadow. You could have flipped this around. Again, there's usually 4 different ways you can set up your fractions at any given problem, but I'm just going to go with this way here. So person's shadow over building shadow, and this would be person's height over building's height. So we have our setup here. Again, person shadow, person height, building height, so the fractions are all consistent. And now we go through our little cross multiplication process. So we have 7.5x is equal to 37,500. Whoops, there we go. And then just like before, we divide out that piece there. And we get x is equal to 5,000. So the Tower of Babel is 5,000 cubits long, according to this diagram here. So once again, it's all about setting up your fractions correctly. So when you're working through this test, this quiz, After you get your fraction set up, just take a quick moment, pause, double check, make sure everything links up, make sure every fraction is consistent. Say your pieces in your head aloud. So it'd be like 7.5, 6.6250. It'd be shadow, shadow, height, height, person, building, person, building. If everything goes the same way, then you have your fraction set up correctly. And of course, you can always plug your number back in and see if the fraction still holds. So if you plug 5,000 back in there, this division and this division should give you the same exact decimal. So more than enough ways to check your work to help you out. That's it for this one. Kind of a short one. Should go well. Hope you enjoyed the video. Have a good day.